All right, let's talk about something that drives every developer crazy: slow web scrapers. We're going to dive into how to supercharge your Python scrapers by going asynchronous. Seriously, if you've ever sat there watching your script crawl, you're going to love this.
So, does this hit close to home? Your scraper technically works, but man, is it slow. Painfully slow. You're just watching the lines tick by one after another, and you're thinking, there's no way this is the best we can do. It's a classic bottleneck, right?
And look, this isn't just some abstract problem. We found this comment on Reddit that just nails it. Humble Harbinger says they have a scraper that needs to make 70,000 requests. Can you even imagine doing that one by one? It's just not going to happen. This is exactly why async Python is such a big deal.
Okay, so let's break this down. To really get why the solution works, we first have to understand the problem. What's causing this scraping slowdown in the first place? So here's the deal. On the left, you've got your standard synchronous flow. Your code sends a request, and then it just sits there. It waits. All that time the server is thinking, your program is doing absolutely nothing. It's like waiting in a really long single-file line. But look at the asynchronous flow on the right. It fires off a request, and while it's waiting, it starts another one, and another one. It's not wasting a single second. We're talking the difference between a traffic jam and a superhighway.
So how do we get onto that superhighway? Well, that's where our asynchronous answer comes in. It's a total shift in how we think about our program's flow, and it's all about taking back that wasted time.
You know, the best way to think about it is like you're cooking in a kitchen. Asynchronous scraper is like making a meal one step at a time. You put the pasta on to boil, and you just stand there and watch the pot for 10 minutes. Only after it's done do you start chopping vegetables. It's crazy, right? The async way is how a real chef works. You get the water boiling, and while that's happening, you're chopping the veggies, you're browning the meat, you're always doing something. You're using your time efficiently.
Okay, so the first piece of the puzzle is something called a coroutine. Just think of it as a special kind of function. You mark it with async, and suddenly it has this superpower. It can pause itself. When it gets to a slow part, like waiting for a website to respond, it just says, hey, I'm going to take a quick break, and lets other things run. That ability to pause is the whole secret sauce.
But wait, if you have all these functions, pausing and starting, who's in charge? Who's making sure it's not total chaos? That's the event loop. It's the manager, or better yet, the conductor of an orchestra. The coroutines are the musicians. The event loop is looking at everyone, sees the violin is waiting for its cue, and points to the flute to play its part. It orchestrates the whole thing so the program is always making progress.
All right, theory is great, but let's get to the good stuff, the results. And I'm not talking about a little 10% speed boost here. The difference is, well, it's pretty shocking. Let's look at the numbers.
Just look at this. The numbers don't lie. To scrape 50 URLs, the old synchronous way took over 52 seconds. The asynchronous version? Under 4 seconds. 3.55. That is insane. And it's not just speed. Look, it uses fewer resources and has a better success rate, probably because it's not timing out as much. It's a total knockout.
Yeah, about 15 times faster. Let me say that again. 15 times faster, just by changing how we make the requests. For a big job, that's the difference between something finishing during your coffee break versus having to leave it running all night long. It's a total game changer.
Here's another way to see it that's super clear. Scraping 5 pages. Synchronous? It's just one after another, stacking up to about 15 seconds. Asynchronous? It starts them all at once. So the total time is basically just the time it takes for the slowest page to finish, around 3 seconds. The waits don't add up. They overlap. It's so much smarter.
Okay, are you convinced yet? Yeah, I thought so. So how do we actually do this? Let's get into the code, and you'll see the basic structure is actually pretty straightforward. The workflow is basically 3 steps. First, you define your function with async def. That's what turns it into one of those special pausable core routines we talked about. Second, you just make a big list of all the tasks you want to run, one for each URL. And third, you hand that list off to async.gather and just let it rip. It takes your whole to-do list and figures out the fastest way to get it all done at once.
And really, it all comes down to these 2 little keywords, async and await. Async is like putting a label on your function that says, hey, I'm special, I can be paused. And await is the instruction you use inside that function. It's you telling the program, okay, this next line is going to be slow, so go ahead and do other stuff. I'll wait.
Okay, so now you've got this incredibly fast scraper. But with great power comes new problems. You can't just slam a server with thousands of requests in a few seconds and expect it to be happy about it. So now we need to talk about scraping smart, not just hard. Because as soon as you ramp up the speed, you're going to start hitting these roadblocks. You'll see a 403 forbidden, which is basically the website saying, nope, you look like a bot, you're out. Or you'll get a 429, too many requests, which is the server politely or not so politely telling you to back off. And that's on top of all the usual connection errors and timeouts you have to deal with.
So to handle this like a pro, you need the right toolkit. This means adding things like rate limiting, so you're not hitting the server too fast. You need automatic retries for when requests fail, but with a smart delay, so you're not just hammering it again. You absolutely have to set a user agent header so you look more like a regular browser. And for the big jobs, you'll need to use proxies to switch up your IP address.
And remember our Reddit user from the beginning? Humble Harbinger? Well, here's the follow-up, and it's perfect. He says the company he built the fast scraper for got their IP blocked. He had to scramble to rotate IPs. It's just a hilarious and very real example of what happens. Speed is great, but without a strategy, you're just going to run straight into a wall.
Now here's a pro tip, a real level-up moment. We've been talking about how great async is for waiting on networks. That's called an I/O-bound task. But what about tasks that use a lot of your computer's brain power, the CPU, like parsing a really complicated HTML file? That can actually block your async code and slow everything down again. The trick is to use something called run in executor to push that heavy lifting off to a separate process, so your main async loop stays fast and free.
And this leads us to our last and honestly most important point. We've talked about how to get all this power. Now we have to talk about how to use it responsibly. Being able to make thousands of requests a minute is a serious thing. Being a good digital citizen is it's not optional. You've got to follow this checklist. Always respect the robots.txt file. It's the website's rules for bots. Read their terms of service. Stay away from scraping personal or private data. That's a huge no-no. Identify your bot with a proper user agent so they know who you are. And maybe most important of all, be gentle. Scrape at a reasonable rate so you don't crush their servers and ruin the experience for actual human users.
So there it is. Asynchronous Python isn't just a tool. It's a superpower for scraping. It gives you incredible speed and efficiency. But the real question is, what are you going to do with that power? Speed is easy. The real challenge is to build something that's not just fast, but also smart, resilient, and responsible. So, how are you going to use it?